So this is unit 9. For some reason, it didn't show up on the worksheet, but unit 9, day 3 notes. These are your objectives. We will be graphing most of the time, but we're also going to get into completing the square, quadratic formula, the discriminant, things of that nature. But most of this work this day is graphing. Okay. Graphing lines, graphing parabolas, which are quadratics, and moving in that direction. All right, so starting here, we are going to graph this function. We're not going to use a table. We're going to graph using the slope and y-intercept. Okay. Last time I kind of used a table to graph using like a function, and then I graph using -2, -1, 0, 1, 2. You can definitely graph that way, but this is not how we're going to do it here. Here we're going to use the y-intercept, the slope and y-intercept to graph. So first and foremost, what you need to know is with slope, okay, with your slope, it's going to have the top number is going to be either up or down. This is your positive or negative. And then at the bottom, it's going to be left or right. This is negative. Of course, that is positive to the right. So this is rise over run, okay? And that little fraction here is how you're going to determine where you're moving, okay? You're going to move this. Of course, it's rise over run. And rise can be positive or negative, and run could be positive or negative, okay? So in this case, this extra number here is our y-intercept, okay? And we talked about this before, but y-intercept, x is always 0, okay? Y-intercept, x is always 0, x-intercept, y is always 0. So your y-intercept, x is 0, and in this case, as your y-intercept, it's -7, okay? And that is where we're going to begin. We're going to begin with your y-intercept. So 0, -7 is here. And if you know for your y-intercept, it's always going to be on your y line. So you start with your y-intercept. And now we're going to use 3/2 to find our next point. So if 3 is positive, we're moving up +3. If 2 is positive, we're moving right +2. Okay? As I said here, up is positive, right is positive. If this number was negative, I'd move down or left, depending on what is happening there, okay? And I'll talk about those as well when we move forward. So starting from your y-intercept, we're using our slope as a roadmap. We're going up 3, starting from y-intercept, 1, 2, 3, up, and then of course right 2, 1, 2. That is our next point. And then starting from this point, we're going up again 3, 1, 2, 3, and then to the right, 1, 2. Okay? I want to show you something that is also true about slope. So if up and right are a part of the slope, the opposite is also always true. Okay? So if it's up and right, down, which is -3, and the left, which is -2, is also always true. Positive, and as you can see, 2 negatives become a positive. So these are actually equal to one another. But this, if it's up and right true, down and left is also true. So if I go, let's say I start from here and I go down 3, 1, 2, 3, and then left 1, 2. That is also a part of my line. So if I started, let's say I started here and I go 1, 2, 3 down, 1, 2 left. You see how it's a part of the point? Same thing here. It'll keep going, and it'll be a part of our point as well. Okay. So these are both true for our equation here and how we graph. They didn't tell me how many points I needed, but I just drew that many points, and I can draw a line to show this is my graph. Okay. Let's turn it over and go here. Again, we're going to always start with your y-intercept. Our y-intercept looks like it's +5. You know, for your y-intercept, x is always 0. and it looks like positive 5 is your y-intercept. So you go on your y line, go up 5, put a dot. That's your y-intercept. Okay. So now we're using this as our slope. Our slope looks like it's negative 3 over 4. So it's down 3. The top number is always up or down, and the bottom number is always right or left. And in this case, it's right 4. Okay? Down 3, right 4. So from your y-intercept, down 1, 2, 3, right 1, 2, 3, 4. Good. But remember, and again, you can go again if you need to. 1, 2, 3, and then 1, 2, 3, 4. Okay? But what did I say? The opposite is also always true. So if it's down right here, down up, it's going to be up 3. This one's right. Left negative 4 is also always true. So from this y-intercept, I can also go up 3. 1, 2, 3. Left 4. 1, 2, 3, 4. Okay. So that is our line, our graph of that equation. Draw a line there. Okay. And that's how you're going to find it. You can find the different points there, depending on how many they ask for. In this case, graph the parabola. To graph the parabola, plot the vertex and 4 additional points, 2 on each side of the vertex. So with these equations here, okay, if you don't see anything in parentheses here and no numbers here on the outside, then your vertex is going to be always 0, 0. Okay, so I don't see anything in parentheses and I do not see any extra numbers out here. This is going to be my vertex. Okay, so your vertex is 0, 0 here. And now I wanted to show you a little something about these type of graphs. This is a quadratic formula or a quadratic equation, not a quadratic formula. This is quadratic equation. If it's a quadratic equation, your graph is going to be a parabola, okay? A parabola. And basically, it's going to look like a happy face or frowny face, okay? Happy face represents when the first number is positive. Frowny face represents when it goes downwards is when it's the first number is negative. Positive C over here means that it's going to look like a happy face, but it's going to move up. And then the negative C means that it's going to look like a happy face, but it's just going to move down on that line, okay? Here with a negative, same thing with a positive C, but a negative in the front, it's going to be down face, but it's going to move up on that line. And then here, it's going to move down on that line, okay? So in this case, of course, this number is positive. Since that number is positive, it should look like a happy face, okay? And it doesn't have anything extra over here, so it's just going to be on the 0, 0 point. This is going to be your vertex. And your vertex represents either the highest point or the lowest point in our parabola. And I will show you. So these are the numbers that I chose to use. I'm using -8, -4, 0, 4, and 8 for my points. And I kind of showed you this last time when we did day 2 notes. But all you're going to do is replace x with -8 first. So I'm over here, I'm going to say 1/4 y equals 1/4 times -8 squared. Get my answer, put that here, okay? So then I'm going to do y equals 1/4 times -4 squared. Hopefully you know that 1/4 times 0 squared is just 0. Y equals 1/4 times 4 squared, and y equals 1/4 times 8 squared. Okay, let's see what happens there. Put those in our calculator for the answer. Sorry about that. Let me move this up. All right, so let's put that in my calculator. I get 1/4 times -8 squared is going to give me 16. So that looks like it's going to be kind of outside of my graph. 16. Then I'll have 1/4 times what? -4 squared, and that gives me 4. Same situation here. 1/4 times 4 squared should give me 4 again. Okay, and then we have 1/4 times 8, and that's squared, and that should give me 16 again. Okay, so 4, 0, 0. 16 is kind of going off our graph, but that's fine. So here, -8, 16, -4, 4, 4, 4, and 8, 16. Okay, these are points on a graph, and we just have to graph those points. I've already kind of graphed 0, 0. Let me do 4, 4, +4, up 4. That's a point. Same thing with the -4, +4. That's a point. And then, of course, 16 is going to go off 8. And then +16 is somewhere up here. I'll just make it right there. And then, of course, that -8, 16 is somewhere like here. Okay, so our graph is going to look like I said, like a smiley face. Okay, that is our parabola. And it wanted us to plot 4 extra points, 1, 2, 3, 4, and then our vertex. Okay, so this is what our squared value is going to look like when you graph it. And here, if you can see it, do you see that this is a single x value? When you have a single x value, it's linear. It's going to be a line. Okay. All right, so next page is here, and they want you to graph with the star, and they want you to graph y equals 2x squared. I'm going to use -2, -1, 0, 1, and 2 for my points. Here, again, nothing in parentheses and no extra numbers, so your vertex is actually going to be 0, 0. You can tell that. So let's go ahead and replace. So we'll replace y equals 2 times -2 squared. I'm replacing x with all of these numbers separately. Y equals 2 times -1 squared. Y equals 2 times 0. Hope you know that is going to be 0. Okay. Y equals 2 times 1 squared. And y equals 2 times 2 squared. Okay. With these numbers, I just chose those numbers because I usually choose -2, -1, 0, 1, and 2 as my x value. You can choose any number here. And again, they want 2 on the left side of the 0 and 2 on the right side. So I picked 2 negative numbers and 2 positive numbers. It doesn't matter which ones you pick. You can pick anything you want. And as long as there's 2 negative and 2 positive, and then you just replace them in here. Okay. So there is no right or wrong in that situation. As long as you get the correct numbers. So this becomes 2 times -2 squared, and that one is 8. Okay. 2 times 1 squared, that becomes 2. This also becomes 2, and this becomes 4 times 2, which is 8. Okay. So when we put it in our when we put it in our graph, okay, this is what we'll get. So I'm going to go over to -2, +8 here, -2, +8, -1, +2, 0, 0, +1, 2, and +2, +8 here. There you go. And this is what our parabola is going to look like when we graph it for that. Okay, good. And using our vertex is 0, 0. All right, so now let's go to the back here. Now, I want to make this -1/3 x squared, okay? -1/3 x squared. And if this is negative, if this first number is negative, it should be a frowny face. So it should go down. Our vertex on this is still 0. We can tell because there's no parentheses in here and there's no extra numbers out here. So it's going to be 0, 0 is our vertex. Okay. All right, so let's figure out how we're going to do this. Now it's going to be y equals -1/3 times -6 squared. Okay, I'm using these numbers here. Y equals -1/3 times -3 squared. Y equals -1/3 times 0 squared, which you should know equals 0. Y equals -1/3 times 3. And y equals -1/3 times 6 squared. Sorry, these are all squared. Okay, I'm just replacing these numbers here with x. Okay, in place of x, I'm putting these numbers individually. That's what I got there. So my calculator, I'm putting -1 divided by 3, of course, times -6 squared. And what do I get for the first one? -12. Looks like it's going to be kind of off the graph. Then I have -1 divided by 3 times -3 squared. -3. Then -1 divided by 3 and then times 3 squared. -3. Okay. Well, the last time did I put -3? -1 divided by 3. And then I should have put -3 squared. I think I did, but I just want to make sure. Good. -3. And then -1 divided by 3 times 6 squared. Should be -12. Good. Should start seeing a pattern. All right, so here are our points on our graph. Okay, there's 0, 3, -3, and then it's 6, -12. So if I said -6, well, 0, 0 is there, and I know -3 goes to -3. That's here. +3 goes to -3. So -6 goes to -12. It's kind of off the board, but that's fine. And then +6 also goes to 12 off the board, and that's fine. So it's basically looking like this, exactly what I said. It's going to face downwards. Why? Because the first number is negative. So you know it's going to have a downward, a frowny face, because that negative in the first number. Okay, kind of wanted to show you that. All right, so this particular one says graph the function. I want to say this says h of x equals 3x squared minus 5. I kind of messed it up there, okay? And it says graph the function, plot the points using -2, -1, 0, 1, and 2, and I actually put it here, okay? So you're going to plot that point using this, and of course, we know that this should be a upward space, and it should be basically moving down. So it should go down 5 and go upwards, okay? Because we can see that -5 on the outside. And then I'll show you what the vertex is in a minute. So let's plug those into to our function for x. So it's going to be 3 times -2 squared minus 5. Okay, and then we'll have 3 times -1 squared minus 5. 3 times or 3 times 0 squared minus 5. 3 times 1 squared minus 5, and 3 times 2 squared minus 5. Okay? All right, so let's see what happens there. We put that in our calculator. We'll have 3 times -2 squared minus 5. Our answer is 7. 3 times -1 squared minus 5, -2. This one is 3 squared, 3 times 0 squared, which becomes 0, and that whole thing is 0, then minus 5, that becomes -5, okay? 3 times 1 squared minus 5 is going to be -2, and 3 times 2 squared minus 5 is 7. Okay, so we have our points there. We have 7, 2, 7, negative 1, negative 2, 0, negative 5, 1, negative 2, and 2, 7, 2 positive 7. Okay, and we're going to graph those. So let's start with here, negative 2, 7. So it's negative 2 and then up 7. Good, that's a point. Then negative 1, negative 1, negative 2. Okay, and then 0, negative 5 is here. And then 1, negative 2. And then 2, 7. Right there. All right. So what is the vertex? The vertex is the point, either the lowest point or the highest point, depending on what type of problem you have. In this case, we have a lowest point. This is our lowest point. This 0, negative 5 is our vertex. Okay. And you could kind of tell because there's nothing in parentheses here, but they do have this minus 5 at the end. That would mean that it goes, the parabola moves down 5. Okay. So this right here is where our vertex would be, moving down. And of course there, our vertex is 0, 0, because that's the highest point and it's going downward. In this way, in this case, it's going upward and our lowest point is 0, negative 5. Okay. All right, so we have that. All right, so we're finished with that one. Let's move on to the next. We have the problem here. And again, they want you to use negative 2, negative 1, 0, 1, and 2, and replace it here. As you can see, negative variable here means that it's going to be a downward, but it also looks like it has that +2, so it's going to move. It's going to go downward, but it's going to move up from 0 up 2, and it's going to face downward there. So let's see. Let's put those input values, which are your x values, into your problem and see what happens. Okay, so this becomes negative 2 squared plus 2. This kind of gives people fits. Equals negative 1 squared plus 2 equals negative 0 squared plus 2 equals negative 1 squared plus 2, and it equals negative, and then 2 squared plus 2. And when you put it in your calculator, it really does matter whether it's in the parentheses or not. So make sure you're doing it the correct way. For the calculator, negative parentheses negative 2 squared plus 2 becomes negative 2. And if you're doing it in your head, you have to make sure that you're squaring that negative 2 without there. You're not going to say, oh, this becomes positive. That is not true. Okay, it does not become positive. You have to square it first. Okay, so now I put in my calculator, I got negative 2 is my answer. Negative parentheses negative 1 squared plus 2 here becomes positive 1. And then negative parentheses 0 squared plus 2, looks like it's probably going to be positive 2. Good, positive 2. And then negative parentheses 1 squared plus 2 becomes probably 1. Good. And then negative parentheses 2 squared plus 2 is probably negative 2. Good, negative 2. All right, so now we have negative 2, negative 1, 1, 0, 2, 1, 1, and 2, negative 2. Okay, let's go ahead and plot all of those points and see what our graph kind of looks like there. So at negative 2, we're going to go down. Good. Then negative 1, positive 1, 0, 2, 1, positive 1, and then 2, negative 2. Okay, so of course, like I said, it goes, I can tell from the equation what our problem is going to look like. I know that the first number here is negative, so I knew it was going to face downwards, and then this extra 2, this is the x-intercept, it's going to make it move up a little. Okay, So that is what our problem is going to look like there, and that's how we would finish that. All right, so now we're kind of through the graphing portion. Right, in terms of simplify your answer as much as possible. We've done this before. We haven't done it in a while, and this is important with quadratic formula, so you really do need to pay attention here. When you have a negative under the square root, yes, it's no real solutions, but it is an I. So I would bring that I out, keep the square root of 80 under, okay? Now we're going to try to break that up. I would say that one is what, 4 and 20 probably, okay? And then I break that up into 4 times 5, sorry, square root of 4, and then that's the square root of 20, and then the square root of 5. So then you know that becomes 2, and that becomes 2. Okay, square root of 4 is 2, and the square root of 4 is 2. 2 2's came out. There's an I already out here. That becomes now 4I, and then that square root of 5 is left over inside. 4I square root of 5. And that's when we were working on radicals. Okay, we were working on radicals a lot there. All right, so for this one, we have I that comes out first because that makes, when you have that negative under there, you bring that I out. The square root of 15, is there any perfect squares in there? Doesn't look like it. 5 times 3, neither one is a perfect square. That's how you delete it. Okay. So this one is, you have a negative on the outside, but then you also have a negative in here. That one becomes I, okay, negative I on the outside. I left the negative there. That negative inside the square root came out to be an I. 27 has a perfect square. I think it's 9 and 3, okay. I'm going to bring that out to be 3. So now, what does it look like? I have that 3 on the outside. I have negative I on the outside. Negative 3I times the square root of 3 is what's happening there. Okay. So that's left over inside. So I believe it. And that is, if you have problems, you need to go back and probably look at your radicals. Radicals are a lot. All right, so now here, y squared plus 4. Y squared equals 4, and they want you to solve the equation. More than likely here, there are going to be some situation, something that you may not have seen before, so pay close attention. If there's no solution, state no solution, okay? So we're going to do the start problem. This particular one, if I took the square root, it's going to be no real solution, okay? So that is no real solution. That's what they're saying. They assume that the variable is a real number. If I can do i's like I did up here, then this will be an imaginary number, but we're not. That's no solution. So here, if you have y squared equals 4 and you're trying to solve, you have to take the square root of both sides, okay? Now, when you take the square root of both sides for an equation, y here is going to equal the square root of 4, but it's always going to be plus or minus whatever your answer is, okay? So you actually have 2 answers there. Y is equal to positive 2 and y is equal to negative 2. Anytime you take the square root of both sides with the equation, you have to have the plus or minus there in your answer. So this is actually your answer. You have 2 different answers. It says separate them with commas. So your y is going to equal to negative 2 and positive 2. That's what your answer is. Okay. Here, same situation. I'll take the square root of both sides. X is going to be equal to the square root of 27, plus or minus. Plus or minus. Don't forget that. So now also I want to make it the square root of 9 times the square root of 3. I know the square root of 9 is 3. And the square root of 3 is still going to be inside. So this is going to be equal to plus or minus 3 times the square root of 3. So they want us to kind of split it up. Remember, that is 2 different answers. So here your answer is negative 3 square root of 3, comma 3, positive 3 square root of 3. These 2 are your answers. Okay, so there's 2 different answers when you take the square root of both sides. And you will be seeing that a lot. All right, so now let's look here. Here, there's a reason why they did these, because you're going to be using them down here. So here, they want you to solve for u. Let's get u by itself. Let's add 16 to both sides. to kind of get the u by itself. So this now becomes u minus 9 squared equals 16, okay? And in order to get this, because it's a square value, take the square root. So this now becomes u minus 9, but if I took the square root of both sides, just like I told you earlier, it still applies. This becomes plus or minus 4, not just positive 4, it becomes plus or minus 4. Okay, both of these are possible. And then I'd have to add 9 to both sides. Now, you have u equals 9 plus or minus 4. Now, I'm going to split this up into two different problems. It's going to be 9 plus 4 and 9 minus 4. It's going to clearly give me two different answers. 9 plus 4 is 13. 9 minus 4 is 5. These are now my two answers. My two answers are, I'll put them down here, 5. So u is equal to 5. U is also equal to 13. U is equal to both of those. Okay? And I found that here. Let's try it again here. We are going to add 24 to both sides. This becomes y minus 6 squared equals 24. Take the square root of both sides. This becomes y minus 6 equals, and then the square root of 24 has what? 4, square root of 4 and the square root of 6 in it. Square root of 6 can't simplify, but this becomes 2. So this is going to be plus or minus 2 square root of 6. Okay? And then I'm going to add 6 to both sides. So this becomes y equals 6 plus or minus the square root of, what am I doing? 6 plus or minus 2 square root of 6. Okay? There's really nothing you can do there. You just got to leave it alone. But they do want you to write it separately. 6 minus 2 square root of 6 and 6 plus 2 square root of 6. Two different answers. Y equals both of them. Okay? Two separate situations. It looks like this. Most of the time you'll see it like this, but you have to know that there are two different answers there within this. It looks like that, but it's still two different answers. Okay? Now, fill in the blank to make the expression a perfect square. For these, this is just showing you, this is like the beginning of completing the square, which you're going to be doing in a second. Okay? So in order to find what fills out here, all you have to do is take this number, take the middle number, -2, divide it by 2. So whatever answer you get, -1, square it. Okay? So -1 squared is 1, 1. So the answer that goes here is 1. This will make it a perfect square. Why? Because in your answer, when you have to square it, it'll be u minus 1 and u minus 1. Okay? Which basically is u minus 1 squared. Okay? You need to know that. All right, same thing here. Go ahead and take that first number, 10 divided by 2. That becomes -5. Square -5. -5 is 25. Okay? So that makes this 25. Now, what happens here is you should know, because that's a positive, all you're going to do is y minus 5 and y minus 5. That becomes y minus 5 squared. Okay? And you'll need that for this. Of course, multiples of 25 to add to give you 10 and 5 and 5. And then it's going to be y minus 5 squared. All right. So completing the square is very, very similar. And of course, you may have seen on Alex, may see it coming up soon on Alex. But what you're doing with completing the square is you'll take this first two numbers, and I like to say plus, and I'll put a little box here. Okay? Then that last number, -12, I'll put a little plus and a box after it. And they're both going to be equal to 0. Whatever, it's equal to 0. All right. Now what you'll do is you'll do the same thing we did up here. You'll take -2 divided by 2. Okay. You'll take this middle number here, divided by 2, which becomes what? -1, and then square it. That's +1. So in this box will go 1, and in this box will go 1. Whatever number goes in this box goes in this box too. Okay. So this number should now be a perfect square. Okay. This number is now going to be a perfect square, and you should be able to factor it. So I would factor it. You know, it's funny because I did not do it this way when I used to do it. I used to do it another way, but I guess it really doesn't matter because you can still do it the same way. It's fine. But anyway, so I'm going to go ahead and factor that. This particular situation, I used to put them on the other side, I think. I want to say I put them on the other side and subtracted, but it's fine. All right, so this situation should be able to factor this. You can combine like terms here and get negative 11. So whatever this is going to be, it's going to be what? Same or different is same. Both numbers are negative, so it's going to be x minus, and then x minus, multiples of 1 that add to give you 2, 1 and 1. So this will be x minus 1, x minus 1. This number over here, it looks like it's going to be negative 12 plus 1 is negative 11. I would go ahead and add that, get rid of it. Okay. And then these two are going to be x minus 1 squared. They're going to be the same, so you can write it this way. Okay. So here, what's happening, they're asking you what's going to happen. Look, it's x minus, and then you put a 1 there. This is for Alex. And in here, you put an 11, positive 11. So that's kind of what would happen. That's what they kind of want right here to make sure you're doing it in correct form. So x minus 1 squared equals positive 11. And then to solve it, we just take the square root of both sides. X minus 1 equals plus or minus square root of 11. Add 1 to both sides. So your x value is going to be equal to positive 1 plus or minus the square root of 11. This would be your answer. Two different answers. Remember that. X plus square root 11, x minus square root 11. This is your answer for completing the square. Okay? All right, let's do another one. Because as always, there's always another one. All right, and this is, again, I'm not sure how Alex will give it to you. I've done it both ways, so you could do it another way, but I'm going to do it the same way just to reinforce. So this becomes x squared plus 14x plus box plus 39 plus box equals 0. I'm going to take this first, the middle number divided by 2. That's 7, and then square it like we've been doing. So 49 goes inside this box. Okay. Of course, we're going to factor this. Multiples of what? I mean, multiples of 49 that add to give you 14. We know that's 7 and 7. So it's going to be x plus 7, x plus 7. And that should always happen. It should always be the exact same when completing the square. And now let's add these 39 plus 49. 39 plus 49 is 88. Plus 88 equals 0. I'm going to subtract my 88. So this becomes x plus 7 squared equals negative 88. Okay? And I'm hoping that, I'm not sure whether they want a, what do they want? Do they want I'm not sure. I don't know if they said real numbers. Let me look back on my look back on the instructions. Look back on what they said. Okay. All right. So they said for completing the square, choose the appropriate form, fill in the blanks correctly, then solve the equation. If there is more than one solution, separate with commas. It doesn't say it can't be negative, okay? Because it looks like there's going to be some i's here. So we'll just keep on going. Square root both sides. This now becomes x plus 7 equals plus or minus, but you know that this is going to have an I there because it has a negative under the square root. So this is going to be plus or minus I square root of 88. Why? Because there's a negative under square root. So I made it an I, but you know there has to be plus or minus when you take the square root. Okay? So looking here, looks like we're going to have to simplify that a little bit. 88 has a 4, I know. And what is it? 88 divided by 4 would be 22. And I don't know. I don't think it has anything there. So this becomes 2. And this becomes x plus 7 equals plus or minus 2, because 2 came out, 2i, times the square root of 22. Okay, so 2 came out, 2i, and then square root of 22 was left over. Now I can subtract the 7. So this x is going to be equal to negative 7 plus or minus 2i square root of 22. That is our answer. And here, what you would do is it's the plus one. This one is the x plus 7, and then it becomes negative 88 here. So this one, yeah, this one is nasty, but it's still, that is how you are going to solve that with the I situation going on. Just because it's not a real number does not mean you can't do it. And you'll be going into multiple I's and nasty stuff once you get down to quadratic formula. So this is how you solve that, okay? All right, so the quadratic formula is next. And of course, I wrote the quadratic formula first. The quadratic formula is something I learned in high school, never forgot. Y equals negative b plus or minus the square root of b squared minus 4ac over 2a. I remember saying that, like, if I die, I want the quadratic formula on my grave, because I want my grandchildren to remember it. Okay, so I go ahead, and that is what you're going to use to solve this, because it says use the quadratic formula to solve for x. And the a here is always represented by whatever coefficients in front of x squared. We have 9. B is going to be equal to whatever's in front of x, which is 3. C is going to be whatever's here when it's equal to 0. Has to be equal to 0. It's negative 1. Okay, so we're going to use this negative b, which is negative 3, plus or minus the square root of 3 squared minus 4 times a, which is 9, times c, which is negative 1, all over 2 times 9. So here, negative 3 plus or minus something over 18, because 2 times 9 is 18. So what I'm going to put in my calculator is just not the square root. I'm not going to put the square root. I'm going to put all the numbers under. So I'm going to put parentheses 3 squared minus 4 times 9 times negative 1. Push enter. I get 45. So under here is just 45. Now I do need to simplify what's under here. The square root of 45 breaks down. It looks like it goes into the square root of 9. I'm using that because it's a perfect square, times the square root of 5. I know the square root of 9 becomes 3. So what does that look like? Negative 3 plus or minus 3 square root of 5 all over 18. Okay, are we done? Doesn't look like it. You should know that if they're out here, we're not worried about what's inside the square root. But the numbers on the outside, if you can simplify them, you should. Okay, if they all can simplify, you should. So this, you can divide everything by 3. If you can simplify everything by the same number. So if I divide that by 3, that becomes negative 1 plus or minus, this is also 1 square root of 5 over 18 divided by 3 is 6. This is your answer. How many answers do we have here? 2. 2 different answers are here. There is a negative 1 minus the square root of 5 over 6, and there is a negative 1 plus the square root of 5 over 6. Both of these are your answers. Okay, if it looks like this, please understand these are still 2 different answers. Okay. All right, so let's move on down here to the starred numbers. All right, so here is, I'll use the quadratic formula to solve. Round your answer to the nearest hundredth. If there is more than one solution, separate them with commas. Let's go ahead and do that. All right, so here, when you cannot you can't do the quadratic formula until everything is equal to 0. So I'm going to add 3x, subtract 1. Add 3x, subtract 1. This now becomes 6x squared plus 3x minus 1 equals 0. Okay? So quadratic formula, A is equal to 6, B is equal to 3, C is equal to -1. So A is always whatever's in front of x squared, B is in front of x, C is in front of, it's the one, is a constant, okay? All right, so using our formula, the formula is y equals -b plus or minus square root b squared minus 4ac all over 2a, okay? We're putting that in our problem. B is going to be -3 plus or minus the square root of 3 squared minus 4 times 6 times -1 all over 2 times 6. Okay, here I would put -3 plus or minus, I'm not sure what that is going to be, over 12. I'm going to put that in my calculator. Okay, so 3 squared minus 4 times 6 and then times -1. 33. That's what I got under here. Okay. Doesn't look like it can simplify at all. There's no perfect squares in there, I don't think. 3 and 11, nope. So there's nothing that can come out. But I can split them up here. This is where you split them up. -3 plus the square root of 33 over 12. And then -3 minus the square root of 33 over 12. And they said the answers to the nearest hundredth, you do have to put this in your calculator. So in your calculator, I put the top needs to be in parentheses. Okay, this has to be in parentheses. And then that has to be in parentheses. So parentheses first, -3 plus the square root of 33. Close that square root parentheses, but also close the top parentheses. You see how that is at the back? And divide that by 12. Now we're rounding to the nearest hundredth, which is the second number. That 8 will make this 3. So your answer for this one is 0.23. And then I'll do it again, -3. Oh, in parentheses first. Parentheses, -3 minus the square root of 33. Close the square root parentheses, then close the top. Divide that by 12. And I get -0.73 because this 8 makes that 2, 3. So this is my answer there. Okay, so they do want decimals, but many times they'll want this. Okay, but sometimes they do want the decimals, so you have to go all the way out. All right, so let's move on to the next one. This is our next one that we're going to be working with. Again, they have to be equal to 0. So add 2x minus 7 on both sides. This becomes 2x squared plus 2x minus 7. A is what? 2. B is 2. C is -7. Okay, we're using the formula, the quadratic formula. -b is going to be -2 plus or minus square root of 2 squared minus 4 times a, which is 2, times c, which is -7, all over 2 times 2. Okay, so it's going to be -2 plus or minus something. I'll put that in my calculator, over 4. Okay, look at that. So 2 squared minus 4 times 2 times -7, and that's 60. Okay. And 60 looks like it does not simplify, but we do have to split them up. Okay, we do have to split it up into -2 plus the square root of 60 over 4, and negative 2 minus the square root of 60 over 4. And then put that in our calculator and get two different answers. And they have to, we're rounding. So parentheses, negative 2 plus the square root of 60, close that, and then do it again, divided by 4, equals 1 point, again, it's to the 100th, 1.43, but that 3 goes to 4, so this will be 1.44. And then finally, negative 2 minus the square root of 60, close that parentheses, and then close the top, divided by 4, and that's going to be negative 2.44, okay? Because again, that 6 will change the 3 to 4, okay? So your answers are here, are there. Negative 2.44 and 1.44. Those are your answers or solutions for that problem, okay? So they did want you to put them into decimals, but I mean to decimals here. But most of the time, what you'll see on Alex are these. They want you to actually do those, okay? But sometimes they'll want you to go all the way out. All right, so last page. We're going to do this middle one. Find all complex solutions. So with these, if you're finding complex solutions, there are multiple ways to do this. But I mean, well, I guess you can try to factor it. I would just go ahead and use the quadratic formula. Here, quadratic formula, I'm going to say A is equal to 3, B is equal to 3, and C is equal to 7, okay? And we know the quadratic formula is negative B plus or minus square root B squared minus 4AC all over 2A, okay? That's our quadratic formula. So negative B, negative 3 plus or minus the square root 3 squared minus 4 times 3 times 7 all over 2 times 3. So it's going to be negative 3 plus or minus something over 6. And let's look and see what that something is. So this is going to be 3 squared minus 4 times 3 times 7. Okay, enter. I got negative 75. Now, if it's a negative 75, you know that it's going to have an I. So negative 3 plus or minus I, but then the 75 has some you can simplify that. Square root of 25 and the square root of 3. Okay, 25 times 3 is 75, but then square root of 25 becomes 5 on the outside. So this now, instead of just I right here, it's actually going to be 5I square root of 3 all over 6. Okay, and since those 3 on the outside can't simplify, that's actually our answer. We are done. Okay, and remember there are 2 different answers there. All right. Okay, let's look at the next one. A here is 5, B is negative 5, C is 2. Okay. So using our quadratic formula, negative 5, okay, because it's negative B and B is negative 5, plus or minus the square root of negative 5 squared minus 4 times 5 times 2 all over 2 times 5. So this is actually going to be what? Positive 5, because 2 negatives become positive, plus or minus square root of something over 10. And we're going to figure that one out by putting it in our calculator. Negative 5 squared minus 4 times 5 times 2. Like that. Our answer is negative 15 under here. Okay. Of course, like I told you before, it's when it has the negative under the square root, we're just going to bring out the I. the square root of 15 is there, and then 10. The square root of 15 doesn't look like it has any perfect squares in there. 3 times 5, neither one is a perfect square. We'll leave it like that. So this is really our answer. We cannot simplify these three. Why? Because this is inside the square root. There's nothing here but 1, basically, 1i. So these two, none of them can simplify, really. But if you did want to kind of break this down a little bit more, you could do this 5 over 10 plus or minus I square root of 15 over 10. So I broke it down so that these are two separate situations now. So now 5 over 10 can become what? Because if I divide this by 5 and divide this by 5, this can be 1 over 2 plus or minus I square root of 15 over 10. Would I do that? No, but they may require you to do that. For the most part, I believe this would be what they want to see, but you could do it this way, as long as you know that they had to be broken into two. Okay. All right, so let's go on. We're in the last stretch. Finding the discriminant. To find the discriminant, basically you're just using b squared minus 4ac. Okay. B squared minus 4ac is the discriminant. If the answer is positive, okay, you have two solutions. If the answer is negative, you have no real solutions. If the answer is 0, you have one solution. Okay, that's the issue with that. So you put b squared minus 4ac, figure it out, whatever that answer is. If it's positive, 2 solutions, negative, no real solution, 0, 1 solution. Okay, so b squared minus 4ac, a we know is negative 2 here, b we know is 7, c we know is negative 3. Okay, so b squared is going to be 7 squared minus 4 times negative 2 times negative 3. Okay, put that in my calculator. 7 squared minus 4 times negative 2 times negative 3. And then get my answer is 25. Positive, doesn't matter what the problem answer is. If it's positive, there are 2 solutions. Okay? So the value of the discriminant is 25, which is positive, 2 solutions. Okay, oh, this one here. So A is equal to negative 3, B is equal to 9, C is equal to negative 1. So B squared minus 4AC is going to be 9 squared minus 4 times negative 3 times negative 1. That in my calculator. 9 squared minus 4 times negative 3 times negative 1. I got 69. Okay. 69 is positive, 2 solutions. Finally, A here is negative 9, B is negative 6, C is negative 1, B squared, so negative 6 squared minus 4 times negative 9 times negative 1. Okay, put that in my calculator. Negative 6 squared minus 4 times negative 9 times, negative 1. Push enter, 0. Okay, 0 means 1 solution. Okay, and I believe that's it. Yeah, that's it for that. That's it for Unit 9, Day 3 notes, ending with the discriminant.